Hello. Um, Hello. So I hope you. Let me present. My network is very bad, and it's really affecting me. So let me fast forward present, and I know you guys will see it as we go on. Going forward, we are going to talk about the computer. Okay. And basically, when we talk about the computer, we are going to focus on some key components and see how these components come together to make up the computer. Okay. So, in this chapter, we are going to talk about how the computer works, the command prompts, graphic user interface, file types and extension, computer programming, then the courses software. So, all the software we need for this course, we are going to run through them. Then, when we are done, I'll also run you through some the algorithm, how to construct a simple algorithm. Okay, so now how does the computer work? So the computer we know is a complex machine, and basically it does simple bitwise operations such as ones and zeros, and these bitwise operations are basically doing some true and false, on and off kind of operation in order to generate these complex algorithms we see today. So when we continue, we see that the three main components of the computer I want to focus on will be the processor, the memory, and the hard disk. Okay, so these are the three main components I would like to focus on. And now, when we talk about the processor, basically the CPU, and you talk about the memory, which is mostly known as RAM. So sometimes people be like, so what's the RAM? What's your computer RAM and things like that. Then your hard disk, which or your compact disk, which we call the ROM, um, read-only memory, the RAM, random access memory, then the CPU, central processing unit. So these three things are the major components as a programmer you should be aware of, and you should know how to utilize them. So this will be okay. So we have a so the relation between I don't know if people are hearing me or not. Hello, can you guys hear me? Oh, so it means you guys can hear me now. Oh, sorry. Then let me go ahead and present. Okay. But my network is quite slow, so let me present. So when you talk about the RAM and the hard disk and the CPU, so anytime you write a code, okay, all the software you have on your computer, Paint, Microsoft Word, whatever software you have on your computer is stored on your hard disk. So if you realize, if you buy a new laptop, okay, especially with Windows on it or Mac or whatever it is, you realize that your internal storage, part of the internal storage has already been used up. It's because the software that are on the computer, which includes your operating system, whether it is Windows or Mac or whatever it is, iOS operating system, whatever device you are using, part of the storage keeps all the softwares on the computer, and that will be stored on your hard disk. So if you take out your hard disk and you try to boot your computer, it wouldn't boot because there is no software to load. That's it. I know people see it weird, but your hard disk is the storage for everything. So you can take it as a storeroom. So like if you take a kitchen, we have a storeroom, and the storeroom we store all the foodstuffs, okay, in the kitchen, okay, okay. So with that being said, now the RAM is a small memory, okay. The RAM is a small memory that loads the instructions you need. So let's say when you turn on your computer, some apps run in the background, okay. But let's take WhatsApp for example. So if you want to run WhatsApp, once you double click on WhatsApp and you start running it, your RAM will load all the instructions that it needs to be able to run WhatsApp and to load the instructions from your hard disk. So from the hard disk, all the instructions for WhatsApp has been stored on your hard disk, and that instructions get loaded onto the RAM. So then the RAM serves as a temporal storage. So back to the kitchen stuff I was talking about. So your hard disk is your storeroom, which has all the food items. Okay. Now your RAM is your kitchen table. So maybe you're going to cook, let's say stew or rice or whatever. You go and get the ingredients you need and you put it on your kitchen table, ready to be cooked. So then the table in which you are temporarily storing those materials you need, those items you need for your food, it, that place is your RAM. Okay, random access memory. It's random access memory because data is saved over there and retrieved. Okay, so it's not structured in that sense. Let me put it in the layman perspective. So then your CPU becomes your processor. So the CPU now takes the instruction from the RAM one after the other, okay, one after the other, and tells us um, tells us how or how what to do. So once you get your foodstuffs on your table, which is your RAM, the table becomes your RAM. Now cooking the food is a processing unit, okay, the process. So when you pick your oil, okay, you pour it in here and pick this next instruction, the next instruction, or the next thing, the next thing. Then you keep on doing that. So the computer keep on running between your RAM and the processor. Now, when you launch a new software, the instructions for that software also get loaded onto the RAM, and that's how it works. So once you turn off your PC, all the data on your RAM is lost. It's not like lost, but like it's deleted. Okay, the RAM is supposed to be free so that when you turn on your PC, you can load new software, new instructions there to run. Now, if you have softwares that are very large, okay, very very large, larger than your RAM, sometimes when you are running it, it becomes slow. It becomes your RAM can only load a maximum of 2 GB, but you can't use all your RAM for one software. So definitely it loads far less than that, maybe 30% of it or maybe at most 40, 50% or 60 of that software. Now, if you click on a button inside the software, you do something inside the software, then it means that your RAM has to go to the hard disk and go and load extra data. Okay, so that's where your computer starts running slow, because it has to go in there and load extra data. So if the software is too big, then the loading of the instructions has to come in chunks, and anytime it goes back to the hard disk to load the data, it becomes problematic. Okay, and that's where your computer will be running slow when you're using larger softwares. So then your processor. So we have different processors, the Core i5, 10th generation, whatever it is. Then the RAM, I think recently we have 16 gigabytes RAM. So that's why the bigger your RAM, that means that the more instructions you can keep inside your random access memory and be able to run them smoothly without having to go back to the hard disk. So a logical question could be that, so can't we run the instructions directly from the hard disk? Can't we load the instructions directly from the hard disk? Now, if you take a hard disk, for this case, it's 500 gigabytes. 500 gigabyte size of data. Imagine you are looking for, let's say, a software, very simple software like music player, just to play music. Okay, imagine you are looking through a 500 gigabyte size of data just to find the instruction for a music player. It will make the computer slow. That's why we have a RAM to manage these simple tasks and for temporal storage. Okay, so if you crop a picture or something, it all stays on the RAM. Those are temporal data you need just to keep your computer going. You don't need all the 500 gigabytes at the same time. Okay, so let me quickly move on. I hope you guys are seeing my screen. Oh, okay, so can you guys hear me? Can you guys hear me? I think people can't hear me. Okay, so continuing from where I stopped, I pray people can hear me. There is no way, somebody should text me on WhatsApp whether they can hear me. So how the computer works, reason why your PC runs slow. So I've explained that, and so now let us talk about the graphic user interface. So whatever is what we call GUI. Okay, whatever you see is what we call GUI, and what the graphics, the buttons you see, this X button, whatever you see are all graphics. Okay, so if I go to my computer screen, you see that all these things are graphics. Okay, so yes, people can hear me. Now, behind these graphics are codes. Okay, when computers came up fresh, okay, when computers came up fresh, I could do this. I could right click. Okay, when I right click, what I see here are all graphics. Now I can go to new and I can click on new folder. Okay, then I create a new folder. Likewise, I can CMD, go to command prompt, then use the command prompt. So in olden days, this is how your computer will work. You will not see any graphics. You only see just text. So when computers started, you only say this. I think if you watch older movies, you see the cursor used to be some underscore and blinks. And from here, I can do everything from here. I can open pictures, I can run files from here. And this is what we call the command prompt. You issue commands to the computer and it executes the task for you. So right now, let me change my directory. So change directory. So now send me to Ojam. Let me go to desktop. Okay. So now I'm in my desktop. When I say show me all the files inside my desktop, so you could see that These are the files inside my desktop: academic files, activity folder, backup folder. This is a software, Google Drive link. Now, this library, new folder, not sorted, Python 101, research 101, and so more. Now, when you come here, you see them here. Okay, so these ones are graphics, and behind the graphics are code. Okay, so in modern programming, we try to put graphics so that people interact with the graphics, because not everybody can write codes. So in this class, we are not going to be clicking on icons and dragging and dropping images. You see, sometimes some people want to develop websites and they'll go and learn how to drag and drop images to create websites. That is a graphic user interface. Here we are going to go to the back end. What is at the background? Okay, what is at the background, so that we can really see what is going on. Okay. Okay, so yes, people can hear me, then I should go on. So if you have any question, you can directly put it on WhatsApp, or you just put it in the chat or on WhatsApp, anywhere I can see it. So so behind this, if I want to open this folder, I just double click and it opens for me. Okay. But if I want to open it from here, from the CMD, this is the olden days, I will just say change directory. Now enter academic files. Okay, so academic, let me see how I spelled it. The spelling has to be accurate. Files, then I, with quotation, then I press this. So now I'm inside academic files, then I press DI. So this one shows me all the documents in there. So chapter 10, PPT, whatever it is, important info.txt. So if I open the folder, you see, when I open the folder, I see what chapter 10, PERT, whatever it is, important info.txt. So I see all of those things, okay, and I can run an app from here. Okay, so let me run one of them. This is a research paper for final year project. No, let me run something. Chapter 10. Let me run this file. So let me run applied electricity PDF. I think most of you are first year, so I can say let me run this. So I say applied electricity dot PDF. Okay, it's not recognized as an internal or external command. Okay, so let me see. I've forgotten my commands. File not found. Oh, file not found. I think I made a mistake with the spelling. Okay, let me see if I made a mistake with the spelling.pdf. Oh yes, so here, according to the file, the P is only one, but here I did a double P. So file not found. So this is one problem with the command prompt. You have to get your commands straightforward. Like, you have to get them straight. Okay. And let me run it again. Applied, even though it's a spelling mistake, but I have to run it as exactly as it is. Let me take the pen and type it. I can just do copy and paste, but let me just type it. So, ta-da! I've opened the Applied Electricity book from here. Yes, this is a very good book for your Applied Electricity course for those in first year. So let us keep on going. So this is the command prompt, and this is the graphic user interface. So let me first put the command prompt on the side. Okay, so on my left side is the graphics, and on my right side is the this one, your command prompt. So you could see you could do anything with this. And as a programmer, this should be your playing ground. Okay, you write direct codes. Behind these graphics are the codes. Okay, behind these graphics are the codes. So if I open this file, okay, and I want to run this apply electricity, I just have to double click, or I can right click Okay, right click on it, then click on open. Doing that right clicking and then clicking on open, all these things are graphics. Or I can come in here and type in the file name and open it from here. Okay, so these are the two interfaces. Now, in this course, what I'm going to teach you is basically how to write the codes. Okay, so our codes will not have graphics. Most of you start a course and you want to start programming and start seeing nice colors and nice pictures. Yes, to be able to have these colors and pictures, we call it GUI programming, graphic user interface programming. So you have to program how the graphics will look. Then you have to also program how the app will work. Okay, so how it will work in the background and how to program how the software will work in the background. Now, when you learn how to program it and how software will work in the background, then you can program. So I shared with some few people. So this software, so the buttons you see here, you see calculate, but behind the button, it's a function, a Python function, and your cumulative credit hours. Let's say you're in your final year, like I do, and maybe so far maybe you've had 119 credit hours, and this semester you are having 20 credit hours. So you want to know how much score you need in order to move from 68, a CW of 68, to get to 70. So when you click on calculate, then it tells you that you need to score 81.9% per course to be able to achieve this CW of 70. So if I'm able to score 81.9% on all my subjects, meaning that my weighted average for this semester should be 81.9 at least, then I should be able to move from 68 to 70 within the semester. Maybe I can set much higher targets, and it says I need what 116.6%. That means I can't achieve it. So your CW target is impossible to achieve and may take you more than one semester to achieve it. So if you want to achieve it, then you have to split it and take more than one semester to achieve it. So this was one of the softwares I did for myself, and it's quite easy doing softwares like these. So this is the graphic side, and the background. I think I lost the code and I'm having this. Else I would have shown you how it works. Or maybe if I find the code, I'll show you one time. So that's graphic user interface and GUI. So graphic user interface is GUI, and this is the command prompt, and both of them basically does the same thing. So later on in this course, we are going to install certain packages, okay, and we'll come to this interface and install them, okay. So where we are going to use what we call pips, like something like pip install, let's say pip install py4Eng. Let me just say it's a Python library. I can install some Python libraries through these commands. So you see how beautiful they load. Let me 3, 2, 1. Oh, why? Don't disappoint me. Okay, I think the network is keeping long. So, oh, collecting PyPDF. So it will come. It looks very beautiful. So we would learn how to do this in later of our course. So I'm downloading and installing some packages I'll be needing, but not now. Okay, not now. So let's leave it. I just want to show you how we can do things here. Oh, it's done. It's already done. There are some of them that are very long, like when you're installing matplotlib and other things like that. So let's go on. So from here, let me go and talk about. I've spoken much about GUI and command prompt interface, and file names and extensions and paths. Okay, so let me explain that in a bit. These are just some fundamentals you need. Okay, so when you look up here, you see that thing that pops up, C semicolon backslash users backslash ojam backslash desktop backslash academic files. We call it file path. Okay. Now let me quickly create let me quickly do something new. Let me quickly do something. Let me say text file. Where is text file? New. Oh, I want to just create a text file. Okay, Google Docs. Well, let me just create a Microsoft Word document. So let me just say test. Okay, so what you see here, this file you see here, let me zoom in, view to large. Okay, so this file you see here, which is the test.docs. Okay, now most of you on your computer, I don't know the kind of settings you have, but most of you on your computer, what you see is file name. What you see is your file's name. Okay, file name. So sometimes you just see file name. Maybe you name the thing, maybe final year project report, let me just say, or you named it assignment. That's the file name. The .docx is the file extension. Okay, so let's take a look from here. So what we have here is, now example, giving a file name like this, my project codes.py. Okay, my project code.py. If you look at it closely here, my project code is the name I gave to the file. Now the .py is the file extension. Now when you say a file extension, it simply means that, hey computer, when you're opening this document, open it with a Python app. That's Py. So the .docx you see here, it simply means that, hey, when you're opening this file called file name, open it with Microsoft Word. So every file has its own extension. Okay. If I create a MATLAB file, you see .m. If you create a video, you see .mp4. Okay, but some of you, you've hidden your file extension. If you want to unhide your file extension, you can go here, go to settings. Okay, go to settings, then and to keep it for future use. So go to settings, then you go to developer mode. So let me say developer mode. So now you're a developer. Okay, user developer features. Let me see. So for developers, so you go to for developers, you just check. Then you come down to developer mode, which is on. Then you scroll down to file explorer. Okay. So when you come to developer modes, you just go to system. Let's follow the trend. System for developers. Then you come down to, you turn on first. You have to turn on your developer mode. If it's off, you will not be able to do something. But if it's on, so you can turn it on. So yes. Okay, then you come down to your file explorer. Then from your file explorer, you say show file extension. Yes, I'm showing file extension. Then show full path in title bar. So this is the path we are talking about. Let me open another one. Let me just say desktop. You realize that I'm coming. No, let me open it from here so that I can see the path very well. So let's open this new folder. So if you realize at the title bar, you see this file path, C semicolon backslash users backslash ojam backslash desktop backslash new is the file path. Okay, and I'll show you how it works. Okay, so from here, you make sure you turn on file extension. Now, once you turn it off, if you turn it off and you come here, you see that file name, you not see .docx. So it doesn't tell you the file's extension, and you cannot change the file extension. But if you turn it on, then you can see your file extension. Okay, so it tells me that the file extension simply means that open this file with Microsoft Word document. Now, if you change this, if you change the file extension, let me change it to .mp4. mp4 is movie. Now I've changed the file extension to a movie file extension. When I press enter, it says, and I click yes, VLC. Okay, because once the computer sees an extension of .mp4, okay, and if I try to run this, I'm going to get an error. Probably my computer might freeze, so I wouldn't run it. Okay, but in reality, it's a Word document. I can right click on it, then I can say open with, then I can go and select Microsoft Word. Open with, maybe choose an app, then I select Microsoft Word. Let me see. Let me select Microsoft Word, then just once. and it's going to open. Nothing is wrong with it. So the file path is just to help the computer identify which software it should use in opening the app or whatever it is, but it doesn't change anything. So if I change this file path to let me change it to MP3, which is music, we get something like a music file. If I change it to what is it? Let me change it to matlabs.m. Yes, so we get a MATLAB file type. I can change it to, just think of any file extension, and you can really change. Let me change it to JPG, like a picture. JPG. Okay, so it looks like a picture now. So, but then in reality, it isn't a picture. It's a computer that is branding it this way to make it look like, oh, you mean this is a picture, but it doesn't mean anything. So the file extension tells the computer that, hey, use this software to open this directory or this document or this file. Okay, but in reality, it doesn't do anything. So I can just change it back to docx, and then turns back to Microsoft Word for us. So that is file name and file extension. So file name dot file extension. So that's how things go. I think now that I've cleared that, I can return. So the next thing I would like to talk about, I think the file path. Yes. So if we want to open this file, okay, there's a path. Now let me open it. Let me right click on it, then say copy as path. When you copy as path, it means you are copying the file path to this. Let me open the file itself and paste the path in there. Okay, Control V. So you realize that you realize that you see this as the file's path. I copied the path and I pasted it here. Now, what does the file path mean? What does this mean? C semicolon slash user semicolon ojam slash desktop slash file name. Now, probably you've seen it a million times. I'm doing all these because I'm assuming some of you are just totally new to the computer itself. Else, I would have just jumped over all these. So when I take when I'm talking about file path, now let us probe through the file path. When I open this and you go to come and put this on the left, then you put this on the right. So when I go to this PC, now this is my Windows drive C. So it says we should go to the drive C, and this is it, C semicolon. When we enter, it says we should go to what? Users. Go to users. When we enter, it says we should go to Ojam. So then we go to that. Then it says we should go to desktop. Then this is desktop. We go. Then it says we should go to what? File name.dox. Now file name.dox is here. And we are here. So the file path just indicates how or the location of the file in the computer can be long or short. Okay, so later on in our programming, sometimes you may have to store a data in a particular file, and you may have to quote the file path, the location of that file. Okay, you have to quote the location of that file, else you can't store your data in that file. Okay, so I hope you understand file name, file underscore name dot file extension. Okay, so file name dot file extension, example like maybe story, which is dot docx, or maybe terminator, which is dot mp4. It's a movie, Terminator. Okay, so that's a file name dot file extension, and this could be the file path. The file path is the location where you saved it on your PC, and that is it. So I think I've exhausted this topic, and I need to move on to the next. So now that we've learned about file path, I think I have some YouTube video. I'll share this slide with you so you can go through. So what's this course about? So we are going to learn about computer programming. Now you have to understand that we have natural language, machine language, and programming. So machine language is a programming language, and higher level language. So if you take a natural language, as I'm speaking, it's a natural language, you can quickly so if you take a machine language, I was checking WhatsApp. Somebody saying, could I please go over the extension? Okay, so I can, I can. So the extension, you can rewatch the video because we are running out of time. We have to end at 9. We have 1 hour 3 minutes remaining. It's quite unfortunate we can't interact that much, but I think this is okay. So natural languages is Ga, Fanti, Evechi, English, French, whatever. Just name it. Any human language you can ever think of is natural language. Well, we invented languages though. It's not natural. So, but it's just natural language. So other languages we also will consider here is machine language. When you say machine language, it is the fundamental form of language. So I'm using this AMA as an example. Wow, what am I saying? So when you take AMA, a simple name in the Akan language, which is AMA. Now, AMA can be written as this: 0, 1, 0, this as A, then the one in the middle as M, then the last one as what? A. So this is AMA in a computer or machine language. So inside the computer's memory, it looks this long. Now this is written based on ASCII. I think ASCII, the full meaning is American Standard for Computer Information Interchange. I think I'm getting it correct. So they brought up a standard that, okay, let us say 01000001 is A, capital A. 01001101 is M, and 00 like, so it's a standard. Hello. Okay, so somebody should give me a sign. Somebody should tell me something. Okay, so you can hear me now. Okay, so I think my network got fuzzy. Sorry. Natural language, higher level language, and machine language. So in natural language, I would say, in natural language, if I'm given an instruction, I would say display hello on the computer screen. Sorry, display hello on the computer screen. Okay, that's a natural language. Now, if I'm giving that kind of command to the computer in a higher level language like Python, I would say print hello, and the hello will be in quotes. If it's a machine language, then we have to put the hello in bits. This is not an actual representation. Actually, if I'm to put all the hello here, it will not fit. They won't fit here. So I just put in some zeros and ones, okay? So then I have to type some long zeros and ones to let the computer perform this action. So you realize that the human language or the natural language is similar, okay, to the higher level language, but the higher level language is not as direct as what the human language, okay. And so the higher level language, which is the programming languages like C++, JavaScript, whatever it is, are the betweener between the machine language and the natural language. Some people learn how to code in the machine language, like going into details with Fortran, whatever it is. I think we have somebody who knows how to write Fortran codes. Okay, so with Fortran, so you can, and even going into details and even much closer to machine language using assembly languages, then that one goes much into details. But the higher level language like Python and C++, they give us commands or text that kind of look like human language, but not too clear. Okay, so that's the three differences. So all human beings basically know this, but those who go the extra mile to know at least one programming language, and some people, especially computer science and computer engineering, go a further extra mile to go this far. But at least, if as an engineer, so if you have this skill, it's okay. Okay, so then higher level languages, so you can go and read them. Now, usually in the other class, I would let somebody read this, then we ask for your opinion. Okay, so try to make meaning from the Python code below. Share your views. Okay, so you can share your views with me. So if you now this the forget about the prompt, the chevron prompt, or like let's say the greater than signs. Say age equals input into bracket. What is your age? And age is equal to int into bracket age. If age is greater than equal to 18 semicolon, print you are allowed to vote. Else print you are underage. Come back when you are 18 years old. This, when you read this, just like a human being, you get to realize that okay, it seems the person is asking for age and he or she is trying to check whether the person is 18 or above and maybe tell the person you are allowed to vote or you are underage and come back next time. So that's what basically a code is good. So with Python programming, even if you don't know how to code, you can sometimes it's readable. You can see it and read it. That's one good thing about Python programming, and that's why it's a good starting background. So I've even trained people from social sciences. There are people who have learned this Python programming from me, from social science, from art and built environment, from sculpture, all kinds of people, even senior high school students, and they understand Python easily because it's readable and it's understandable. Even from your first reading, from the first time reading this code, at least you can have a guess. Okay. But by the way, there are some complicated ones though. But for now, it's readable. So the next thing we have to do is looking at the Python programming language. Now, when I started this course, I used to do it in 3 weeks. Okay. But this one has been extended over 2 months because one, we are students and we have academic work to do, and I don't want to stress people within 3 weeks. That's going to be too stressful. Too stressful. Okay. Then some career options for you: data scientist, artificial intelligence engineer, web development, DevOps engineer, data engineer, software developer, and so on and so forth. So software for the course. So the software you are going to use for the course is the Python interpreter for Windows or Mac, Visual Studio Code for Windows or Mac, then PyDroid 3 for Android phones, and it's supposed to be Python for iPhones. Yes. So these are the three softwares or the softwares we'll be using. So install the appropriate one. So how to use the Python interpreter? There's a video on it here. When I share it with you, you can click on the link and watch them. So then how to use Visual Studio Code? Then that is it. So we've not ended for today. We've ended the first session for today. I'm going on to the second session. If you can still hear me and see my screen, please send me a message, a WhatsApp message, so that I can really check that thing out. I want to see if people can still hear me, and you can send in your questions if you have any. Okay, so we are going to the next phase of our programming lesson. Okay, We're going to the next phase of our programming lesson. So the next phase is what I call algorithm. Okay, so briefly, let's skim through this. I'll add this algorithm part to the book, to the slides. So let's learn about algorithm, flowcharts. So when you talk about an algorithm, okay, I think most of you have heard it before. Okay, thank you. Now people can hear me. So we talk about algorithms. So algorithms can be expressed in what, three ways? Okay. So this is the algorithm flow chart. But then algorithms can be expressed in three major ways. Okay. First, when you talk about an algorithm is simply saying this is the steps you need to follow to achieve a result. Okay. So let me put it in simple terms. So steps to achieve a result. Let me just put this. I think this is the simplest definition I can craft off head to achieve a result. So that's the definition for algorithm for our class for now. You can go and learn about complicated ones. So let's say let me give a simple question. So let me say write an algorithm to let's say write an algorithm to determine, or let's say to calculate the modulus of a complex number. So let's say, recently I did some tutorials for the first year, so it's still in my head. So write an algorithm to calculate the modulus of a complex number. So now we are to design a step-by-step approach in calculating the modulus of a complex number. So how do we do it? Now we can have the algorithm in a written form, or you can have it in a flow chart. So you see flow chart. I'm going to do it in a written form, then later on we go in a flow chart. Now anytime you are constructing an algorithm, think of the computer as a baby, someone who doesn't know, like empty head. Okay, so if you want, let's say, a class 6 student to be able to calculate the modulus of a complex number, what do you tell him or her? Okay, how do you instruct him to do whatever? So first we say step one, we can say step one, maybe start code, or maybe start the code, or start the program. So start program. I know it's a class 6 student is a human being, so we don't need to start it. Okay, but just because for the sake of the course or coding, we say start the program. Always step one is start the program. Okay. So step two, now once the person start the program, what should the person do? Okay. So here we want to calculate the modulus of a complex number. So let's say a complex number given by the user. Okay. So in this case, a user is going to use our software, and the user is going to type in a complex number. Okay, so let's say user in the form a plus bi. Okay, so the user is going to enter a complex number in that form, a plus bi, and we are to calculate the modulus for the user. So when we start the program, the first thing we have to do is maybe ask the user for input. Okay, that's the first step. So I'm creating an algorithm. So algorithms are very simple. Two, then I'll say my step two, let's say step three will be what? Ask the user for an input. Now, once we get the input, so sometimes best when you're writing an algorithm, you go with an example. So let me say example, let me pick two, no, 3 plus 4i. Okay, that's an example. Okay, so let's assume that the user entered 3 plus 4i as an example. It could be any number, but let's assume that. So the next thing we have to do is what? Maybe pick the real part and the imaginary part. So example, so we have to pick the real and the imaginary part. So the real will be what? Will be equal to what? 3, and the imaginary will be equal to what? The imaginary will be equal to 4. So when the user enters 3 plus 4i, we don't need a plus, we don't need an I. So we tell the computer, hey, when it enters the real number, pick 3 and 4, or pick the numbers in there. Okay. So once we are done with step 3, now step 4 will be that calculate the modulus using the formula. Let me say, let me write it mathematical enough. The modulus is equal to what? Square root. Let me just put square root of what? Real square plus imaginary square. So then the computer will use this formula to calculate. So it picks the real, let me make this imaginary MIG. So the real squared and imaginary squared. Okay. Then the step 5 will be what? Display output. Okay. So example. Yes. So example will be this square root. Let me put in, so square root of what? 3 squared plus what? 4 squared. So I'm using the example as a case study, and that's going to give me what? 3 squared plus 4 squared. I think the answer is 5. I don't know. I think the answer is 5. If I'm wrong, fine. So example, you paste like 5. So we display 5 to the screen. Okay. Then the last step, step 6, is what? Stop program. Voila. This is an algorithm I've successfully described. Even if the child doesn't know anything, or whoever you are dealing with doesn't know anything, the person can follow these steps to be able to calculate. So in case another example comes up, let me put these examples in different colors so that people can really. Let me put this one as my question 1. Okay, and I'm going to write it question 1. So this is my solution, the alternative solution 1. Now there will be another alternative way of writing algorithms, which is my alternative solution 2. Okay, now in this case I'm going to use flowchart. Okay, so instead of writing them out like this, I'm going to use diagrams to represent how things should be done. Now to do that, we are going to use a software we call draw.io. But this algorithm, I'm going to write the same algorithm as this, as my alternate 2, but I'm going to use boxes and diagrams, okay, to draw it. So first, I can say that now we have to learn the meaning of these boxes. So you can see square boxes, oval shape, circle, diamond shape, parallelograms. These are all the shapes. So let's go online and learn about these shapes, okay? So flowchart symbols. Okay. So when you have a box, a square, a rectangle, let me just say a rectangle, it means a process. Something is happening. Okay, a process. Something is happening inside the computer. When you see this one, the parallelogram, that means you are taking an input. Sometimes it's also used for displaying an output. Now, when you have this oval shape, it's a terminal. So that's start code and end code kind of thing. It's a terminal. So we are going to focus on these three: um, process, input, terminal, and decision. We'll use decision later. Then database, when you are storing the file into something. So these symbols are used to represent an algorithm. This is the flowchart method. Okay, so let us see. So from here, the first thing we have to do is start the program, and I'm going to use my oval shape, which is what terminal. It's used for terminal stuff. So I can say start program. Okay, so the first thing that the computer should do is start program. Now the next thing the computer should do is to ask user for input. So asking for input, we use the parallelogram as the symbol suggests, because if you check here, you see we use what input. This is for input. So we go in with the input. If I'm running fast, please prompt me. Okay, so someone is asking. Yes, I'll be sharing my slides with you. The slides I've prepared, I'll share them with you, and you can use that. And this online video will be there for a review, and the slides will also be there, and anything you need. And I'll also be there. You can text me anytime if you don't understand anything. So you have a PDF file, you have an online video, and you have me as well. So your moving forward will be simple. So start program, we take input. Okay. You said I'm running too fast. Okay. Let me take it again. We have 36 minutes more. So please ask specific questions so that I can go over. I hope you guys have understood this part. We've been given that we should write an algorithm to calculate the modulus of a complex number given by the user in a form a plus bi. So this is a question. This is a problem. So we are going to write a computer code. Okay. The computer code we are going to write, in order for us to write the computer code, we have to design our algorithm. Okay. We have to design our algorithm. And our algorithm to is simple. Okay, so yeah, so our algorithm is a step by step. So in simple words here, a steps to achieve a result. Okay, a step by step approach in achieving a result. So the first step to calculate the modulus of a complex number, you have to start the program. Since in the question says what by the user, meaning that the user is going to make an input. So in that case, when you start the program, you ask the user to make an input. And I'm giving an example. Example of the input can be, let's say, 3 plus 4i. So the user makes the input. Okay. Um, Once the user make that input, then the next one will be what? Pick the real part and the imaginary part. So you tell the computer to pick the real part and the imaginary part. Somebody will say, so how does the computer know this is real, this is imaginary? Well, I'll explain, I'll talk about that later. So you pick the imaginary part and the real part, which in this case, based on this example I gave, the real part is going to be equal to 3, the imaginary part is going to be equal to 4. Okay, let's assume the computer knows which one is imaginary, which one is real. Okay, then from here, I said once it has been picked, the computer should use this formula, which I'm going to write it in Python. There's a way of writing formulas in Python. Okay, we'll learn about those things later. So with the real part, you should square it and add it to the imaginary part squared and find the square root. And I did an example here. 3 squared plus 4 squared, all square roots will give us 5. Then once the computer is done calculating this, now display the output, answer is equal to 5. Then you stop the program. So this is a step-by-step approach of solving the modulus of a complex number given by a user. Now, I'm saying that in algorithms, you can write it in an English form like as I've written here, or you can use diagrams to represent it. So I've written it in an English form, as you see here. And I'm now coming to use diagrams to illustrate how it looks. Okay. So from here, we when we start a program, the next procedure is to take input. And the symbol that is used to represent input is this parallelogram. We saw it online. Okay, I'm going to give you this. So input is used for input. So this symbol represents input. So then what are we going to input? A complex number. Or you can just say complex number. Input a complex number. Okay. So that's what the user is going to input. Okay. That's step 2. Now, once the user inputs a complex number, the next thing we want to do is what? The computer should pick the real part and the imaginary part. Now, the computer doing that is what? A process. Picking the real part and the imaginary part is a process, it's an internal process. Okay, so we move on to this. Then we say, hey, pick a process. So, pick, so the computer what? Let's say, maybe picking the real and imaginary parts. Okay, so that process is going on. So it is picking the real and imaginary parts at this stage. So once it is done picking the real and imaginary parts, the next thing is to calculate using the formula this. So the next thing is what? Calculate the modulus. And calculation is also a process. Okay, so if you look at our diagram, it's a process. Doing the calculation is a process. So the next one we say it should what? Calculate the modulus. Okay, and the formula is what? Let me write it in latex form. Real raised to the power 2 plus imaginary raised to the power 2 or raised to the power 0.5 or raised to the power 0.5. So okay, so we tell the computer to calculate the modulus by using this formula: real square plus imaginary square all raised to the power 0.5, which is square root, and to get an answer. Then from here, the next thing it has to do is what? Display the output. But we use this for input, so we can still use this one for what? Output. Okay, we can still use this for output. So let us use the input symbol for output. Let me bring this one. That's what we do. So we say display output. Okay, display output. So the computer will display the output. It could be 5, it could be 10, depending on whatever has been calculated. And once the computer displays the output, then the last step is what? Stop program. So stop program, we go back to this oval shape and we say stop program. So stop program, that ends it. Okay, so this becomes a graphical way of writing an algorithm. Now, for the purpose of this course, anytime I give you projects, I'll require you to submit an algorithm to explain how your code is running. It's very important. Initially, when I used to teach Python programming, I don't ask people to write an algorithm. But later on, I got to realize that when they begin to write algorithms, they write more efficient code and it takes them less time. If you don't write an algorithm, it will take you more time. Okay. Now, this algorithm can be shallow. Okay. Somebody can write an algorithm that is very detailed. Now, with the same question, let me write another algorithm. This time around, I'm going to make my algorithm very detailed and technical. Okay, so first, I'll just say, I'll repeat this part. So start the program, Control C, Control V. Or if I want, I can write it this way. So maybe ask the user to input the real part. Okay, so instead of splitting it, I'll just ask the user to input the real part. Example 3. Then my step My step 3 asks the user to input the imaginary part. So somebody can also decide to do it this way. Okay, it's not, the algorithm doesn't have a formula. Okay, so that's 4. Oh, I made a spelling mistake here. So example. So then the next step 4. Somebody can say, so after this one, maybe find the square of 3 of real parts. Okay, so that example, that will be what? 3 squared, which is going to give me 3 is 9. There's step 5, find the square of the what? Of the imaginary, let me put imaginary parts, which is going to give me, like example, saying 4 raised to the power 2, which is going to give me what? 16. Then someone will say, okay, step 6, okay, sum them. So then example, we have what? 9 plus 16, which is going to give us what? 25. Then step 7, find the square root of your answer, which an example given will be what? Let me just say 5. So if you find the square root of, so let me just say 25 raised to the power what? 0.5 is going to give me what? 5. Okay. Then the last say example, wait, step 8, display the results on your screen. Then which it will maybe say example, answer is equal to 5. Then step 9, end program. So we've still solved the same problem. This one used 6 steps to describe his algorithm. This person used 9 steps to describe your algorithm. It doesn't matter, okay? It doesn't matter how detailed or how shallow your algorithm is. Once there's an algorithm, it becomes easier to write your program, okay? So it becomes very easy to write your program. So that's all what I'm trying to illustrate. Somebody can write an algorithm in a totally different way. The person can say maybe alternate 3, let me just say alternate 3. So person will be like other functions in Python that can find algorithm. So you just take a complex number, blah 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 blah, use this formula, use this function, and it gets the there are a lot of steps. I can write a million steps. I don't want to ask to waste time. So you get to realize how to write an algorithm. Okay, a step-by-step approach. Now let me take another question. Somebody should post a question and let me answer it. So tell me to write an algorithm on how to solve something. Okay, so that I show. So somebody is asking, what are we drawing on the right side? So the right side is what we call the flow chart. Okay, we call it the flow chart. It's also an algorithm, flow chart. Okay, it's also an algorithm, but it's in a diagram form. I want to increase the size. Let me put it 40. Yes, the flow chart. So the flow chart is a graphical way of representing an algorithm. This is normal sentences, and this is the flow chart. And you can see this and that are the same. Ask the user for input. So it says input a complex number, pick a real part and an imaginary part. It says picking the real and imaginary parts, then calculating the modulus using the formula. So calculating this using this formula, which is a process, then displaying your output, display your output, end program. So this is the same as that. They are the same, no difference. This is the same as that. Only that this is what we call flow chart. And this is just normal statement, normal statement. So you should learn how to do this, and that is going to go a long way to help you in your programming journey. Once you write an algorithm, maybe let me quickly write the code for that. Okay, let me quickly write the code for that, just to whet your appetite. So I'll show you how I look at the algorithm and how I translate the algorithm into a code. Okay, so now that I have my flow chart on this side, okay, now that I have my flow chart on this side, let me put it. So let me just call it day one. Okay, let me just say day one.py. I create a Python file. Somebody saying how to find the mean of result from a student in a semester. Okay, so like the average score that's coming from what? I mean name Sambo. Yes, Sambo. Okay, write a function to find the slope of a line. That's nice. That's great. Okay, so let me first convert this one into code. So I can so let me close this part so that we see how we can deal with it. So the first thing is to start the program. The user will start the program. The next thing is what? Input a complex number. So it means I need the user to ask for a complex number. So let me say maybe asking the user for input. Okay. Now this is called comment. We'll learn about it tomorrow. In our next meeting, we'll learn about these things. Okay. So I've written the first command. So the next thing I have to do is picking the real part and imaginary part. So that's the next code I have to write. So picking the real and imaginary parts. So then that's the next code I need to write. So how do I pick the real and imaginary parts? Let me assume that the number, okay, that was entered earlier is equal to, let's say, 3 plus 4i. Okay, 4i. Now I have to use some techniques. Okay, so the real part is always the number that comes before the plus sign. So I can say real. Okay, real is equal to when I pick the number, okay, then I say dot index, forget about whatever I'm writing, index of the plus sign, okay, then I pick number, then I pick a square bracket, so I say start from 0, so you get to the index of the plus sign. This one simply means that start from the beginning and cut all the way till you get to the position of the plus sign. Okay, so cut from the beginning till you get to the position of the plus sign, and that's the real part. The imaginary part is going to be the number. Okay, the number, and that one start from the position of the plus sign. Start from the position of the plus sign and stop at I is the last number, right? So stop at the last number, which is the length of number. Okay, so then I have that. So let me expand it so that I can see what I'm writing. So this one would get us, from the example, this one will get us what? Real is equal to 3. Let me just remove the underscores. I'll talk about that one later. Real is equal to 3. Then we'll get imaginary is equal to what? 4. It will pick them. But then we need to convert them into integers because they are integers. So I will say that int into brackets int, so convert all of them into an integer for us so that we can work with them, so they no longer become complex. Okay, so the real number is 3, the imaginary is 3. So now the next part of my algorithm tells me to what? Calculate the modulus. So I can say calculating the modulus. Now the hashtag, the ones you see here, they are just comments, okay? They are not part of the code. The computer will not run them as a code. They are just like you are making notes in your own code, okay? So to calculate the modulus, let me call it, let's say, yes, modulus is equal to, so then I have to find the square of real. So I'll say real square in square means we put 2 asterisks, okay, in Python, plus imaginary square, then all square roots. Okay, so square root is raised to the power what? Raised to the power 0.5. Then the last step is telling me to display output. Okay, so display output. Okay, so then I say to display output, I say print modulus. Okay, now I just don't want to print the modulus like that. I want to print maybe some statements, maybe answer is equal to, then I print the modulus. Okay, so now let me run my program and see if it works. So when I click on run here, now it's running. So it says enter a complex number in the form a plus bi. So let me test it. 3 plus 4i. Oosh, indices slicing must be integer, not tuple. Oh, okay, so they said it must be an integer, not a tuple. Okay, let me see. So number is a string, index, no, then I'd say, sorry, I used the wrong thing. So let me see. I'm coming. This one, okay, so let me use find. So instead of index, let me use find. Then let me use find here. Okay, so what I'm doing currently is what we call debugging. Debugging is when there are errors in your code and you need to go and correct them. So once you write your algorithm, then you go and write your code, then you debug your code to make it better. Okay, so let me test it again. 3 plus what? 4i, and it's telling me string must be an integer, not tuple. So that means I'm using the wrong this one. Let me see. I want to find something. So from here to, I'm coming. Let me run something quickly. New terminal. So quickly, let me run my Python here. I'm testing it. So then I'm going through all these mess. I want you to see how programmers go through these things. So let me just test it. I'm testing something here. So I have a number 3 plus 4i, okay, and I run this and I say number dot index, okay, plus, so what is the output? I'm unable to see the output. That's the problem. It's saying 2, so 0, 1, and this 2. Yes, so I don't know why it's giving me problem. Number dot, so I don't know why this is giving me problem. Oh, I think it's a square bracket, so let me see. Number then let me say 1, 2, 5, 0, 1, 0. Okay, let me say 0 to 3. Okay, so number, so we have 0 to 3. Okay, so I'm supposed to use a semicolon, not this. Okay, that was a problem. So it's supposed to be a semicolon. So let me start from here. Not a comma. I use a wrong one. Semicolon, not a comma. Okay, so now I've found my problem. Now let me run it again. So I'm debugging, I'm correcting the errors in the code. So 3 plus 4i. Okay. Oh, they said invalid literal. Base 10. Okay. Now let me go and make another correction. So sometimes this is what takes time from students. So plus 1. Now somebody's like, how do I know where I have to make the corrections? Yes, you get to know. Once we go on, you get to know how to make the corrections. So I'll try again. 3 plus 4i. I'm going to fail again. Yes, because of this. So then I go and do this minus 1. Okay. Then I run it again, and this time let me look through. I think this time, yes, everything will work. I think yes. So yes, so everything will work. Even sometimes you will think everything will work and nothing works. So answer is 5.0. Okay, so I've simulated what you are going to be doing. So from the question to a simple algorithm, which the algorithm can be in this form or could be in this form. Okay, the algorithm could be in this flowchart form, which displays a step-by-step approach of how it works, or this form in an English form. Okay, but I'll let you guys, anytime I'm going to give you projects today, and I'm going to send it to you in your email. Now you'll be required to write an algorithm. I'm going to give you a question. You'll be required to write an algorithm, a simple algorithm. Okay, then you submit it on Google Meet. Sorry, Google Forms. I'll create a forms. You go there, you open your draw.io, you create a simple algorithm. I'm going to send you these flowchart symbols, so you can look at them. Now when you scroll down here, 18 flowchart symbols. So this is a flow line, terminal symbol, process. Terminal symbol indicates the beginning or end of a flowchart. Okay, so that's why I use this to say, I use this for what? Start program. So the beginning or end of the program. Then we have what? Process. So process represents a step in a process. Okay, this is most common component. Then decision. So where you have to make a decision. Okay, so maybe I may write one more algorithm where we need to make a decision. Okay, and we'll see how it goes. Then decision symbol. So this input or output here. So we're taking inputs from a user and we're making output or displaying it here. So input or output symbol. So sometimes indicates a process of inputting or outputting. There are some things there. Okay. Then annotation indicates additional information regarding the process. So this is where you can give comments in your code. So if you realize, I was writing some comments in my code. So I was writing some comments in my code and telling some additional predefined processes. Okay, so I can run my code again and deal with more complicated ones. So I can have 45 minus 7. Who can predict what will happen? It will fail. Yes, because in my code I limited it to plus sign here, but here the user was inputting what a negative imaginary part. So my computer didn't know what to do. because I limited it to a plus sign. So only positives will work. If I run it, only positives works. So now you get to see that my code is limited, and that's why people come up with updates. So if you then say like, oh, software update, software update. They've brought new versions to it. So I can say -4 plus 7i. This one will work because what is in between them is a plus sign. So I got this, okay. But then if I put a subtraction sign in between, that means that I have to put something like, let's say -4 plus maybe -6i. This one will work because there's a plus sign, okay. Then I get my answer. But once you remove the plus sign, then you get everything wrong. So if you have both the real and imaginary components being negative, you have to still introduce your plus sign, okay. So that's my software. This is a simple one, and I was able to write it out of this algorithm. Okay, so now let me solve one more problem with the algorithm, then we close. Okay, so so let me write another question. So let's say question two. Um, question two. So question two says, let's say uh, allow, so determine whether or not a user is a first class student or not. Okay, so the user will enter a number and we want to find out if the person is a first class student or not. Okay, so I can go straight forward and write the English algorithm, like let me say alternate one. Okay, so the first step will be what? Step one will be what? Maybe start program. Start program. Let me check if somebody has a question for me. Somebody wants to see the code. So, hey, some people want the Python file. But are you going to use it for your midterm? Oh, sorry, your end of term. But I'll share it. I'll share all of them in the code. I'll share all of them in the code. Okay, so let me see. So start the program. Now my step two would be what? After we start the program, what should we do? We want to see if the person is a first class or not. So we say ask for input. Okay, and the input here we are expecting what? A CW. So let's say CW of, let's say, 79. Okay, that's 79.45. Okay, that's my step two. So step three, what I would do is when I get this, I would say I'll make a decision. Make a decision. Okay. So if the CWA, so make a decision. It's saying decide. So no, let me put make a decision. That's better. So make a decision. Now the decision will be based on this. So let's say CWA. So if the CW is less than or equal to 100, then you're a first class student. So, or maybe 70, your CW is greater than 70 or equal to this one. Okay, or simple put, if no, simply put, if your CWA is greater than or equal to 70, then you're a first class student. But we know somebody can input like 100 and above, maybe 105, which doesn't make sense. But let's assume that the person is rational enough. So we are going to make it is met. Okay, else display what? Not first class. Okay, then the last step will be what? Step 5. stop program. Okay, so the last step will be stop program. So with this steps, we have to now let us follow these steps and draw our algorithm, like our algorithm structure. So first I start with this one means terminal. Okay, then I click start program. Let me just say, okay, start program, then ask for input. So input, we are going to use this triangle. What is that? We're going to use this triangle down here. So let me go online again, and it says that what input and output is the parallelogram. So I drag and drop. Okay, so then I say, so I'll take enter your CWA. Let me say enter your CWA. Okay, so once I've entered the CWA, the next thing I have to do is make a decision. Now to make a decision, let's go online and see. This is decision symbol, so shows a step that decides the next step in the process. This is commonly a yes or no or true or false question. So we have to make a decision whether the person is first class or not. Okay, so we say, so maybe is CWA greater than or equal to 70? That's the question. Let me expand this. Okay, so is the CWA greater than or equal to 70? Now, if it is yes, okay, so then let me do a process. So then if it is yes, display first class. If the condition is met, else display second, not first class. So then we are going to make a display. So display, we use the triangle, sorry, the parallelogram. So we put it here. So then say maybe display, let's say first class. Okay, then we put another one here, display what second, or let me say not first class. Okay, so we use this if it is true. So then I can write here true. So if it is true that the CW is greater than 70, we display first class. Then I put another arrow to this place. Now if it is false, we display, if the thing is false, we display this. So let me zoom in a little. Then once we are done with this part, the next thing we have to do is end program. Okay, so then all of them will come together to end the program. Okay, so if I open this one wide, you get to realize that the algorithm here, it says start program, enter CWA. Is the CWA greater than 70? Is the CWA greater than 70? It's supposed to be a question mark. Now, if it is true, if it is true, then display first class. Else, if it is false, then display what? Not first class. Then after that, end the program. It's a simple algorithm. Now, with this algorithm, I can go and write my Python code from this algorithm. So let me go here. Let me create another one. Let me say first class code .py. Okay. So the first step in my algorithm is saying start program. The user will start the program. Enter CWA. So I have to take an input. So ask the user for CWA. Okay. So let me just put CWA as my variable name. Then I say input. So enter your CWA. Now, don't worry if you can't write the code for now. I just want to show you how we write algorithms. Just so this is the lesson for today. How to write an algorithm. You don't need to start writing the code. Okay. Later on, we'll learn how to write the code. But for now, let us write the algorithm. The second one is make a decision. So we can make a decision with an if statement. So if you convert CWA to an integer, is it greater than or equal to 70? If it is yes, then print what? First class. Then if it is no, else print not first class. Okay, so you can see make a decision, then it ends the code. Okay, so when let me run this code and let's see if it works. Okay, so let me enter a CWF. Let me say 69.99 invalid literal for int base 10. So it's saying that it cannot convert 69.99 into an integer because it's a decimal number. You learn all these things. Yes, so this is what we call debugging. So I have to come back to my code and make changes. So that way I'll just say float because it's a decimal number. Most of the CWs are in decimal number. So then I run it this time. I intentionally make mistakes just for you to understand that it's not always going to be perfect. Okay, so let me 0.99 and says not first class. When we run the code again and we put in 70.01 first class, so our code is working. So algorithms helps you to write code simply. So today we are going to give you a problem, okay? Then you'll be required to write the algorithm for us. Simple. We've come to the end of our class. If there aren't any question, I'll make a summary of this, the most important ones that you need. Then you learn how to use them. Uh, delay, alternate process, data, documents, multi-documents, preparations, display. Okay, you can also use this one for display, a machine display, a manual input, data or information into the system. So we could have also used this for manual inputs here. I don't know, do we have that symbol here? I don't think we have that symbol here, like a trapezium, some kind of trapezium. I don't think we have that symbol here. So then these are some different kinds of arrows and things like that. So we'll give you an assignment, a project today. Then you submit it in 24 hours. It's supposed to be 48, but so somebody's asking, will draw.io work on mobile phone? Yes, because somewhere. What do those things mean? And we'll start writing serious Python codes, and we'll give you projects on that. And with a project, you have to write the algorithm.